Hello, intrepid geonauts. So today we are working downstairs in the laboratory on the next lab in your science interactive package. We're going to be working on weathering and erosion. So let's go ahead and get started. Okay, so welcome back to the weathering and erosion. We had a little change of scenery. So what you're going to need a couple of beakers, your graduated cylinder. This is the screw trap jar that they're talking about in the lab. You're also going to need your acetic acid, which looks like this, your vinegar. And if you're working on a surface you don't want to get messy, they have a puppy pad for you. I'm working on my lab bench specifically because I want to be able to get messy. So let's take a look at our lab. So place the underpad down. That's the puppy pad. Your granite, shale, and limestone specimens. So those are actually in this bag right here. And grab those out. Those are limestone, shale, and our granite. I'm going to start off by showing this with the granite. We're going to have our scale. If your scale is already set up, great. If it's not, there's a little video on how to set up your scale. Put in the batteries, you take the lid off. And for each one of these, we're going to want to, let me grab paper towels. I'm used to simply doing labs in here. Grab a paper towel, grab your specimen. This is the granite specimen. Wipe it off, make sure there's no debris on there. There really usually isn't. Turn on your scale. Unwrap the batteries on your scale. This is one of the scales I haven't used before. Some of the batteries I found in one of, actually, the reason I'm not using the one in your kit is the batteries weren't working. They were actually corroded. If you find batteries that are clearly not working in your kit, let me know. I already informed the publisher. So that's what your kit looks like. Check the batteries if it's not working, but now it's zeroed out. If it's not zeroed, you can just go ahead and zero it. And we want it in grams. So you press M until you get grams. And then you weigh your specimen. Yours will weigh differently because they're rocks. There's a lot of variation. You do that for each one of your samples. So you're going to go ahead and you're going to pour 100 milliliters of the fine gravel. So fine gravel is this stuff right here. It looks like aquarium gravel. I'm going to measure out 100 milliliters of that. Is it going to be super precise? Probably not. But good enough for government work. So you can see mine is good enough for government work. You're going to want to throw that in there. Once again, that gravel came from your weathering bed. You're also going to measure in 50 milliliters of water. I'm going to be putting this away right away, so I'm not going to do that. So you're going to measure 50 milliliters of water, put that in there. And then you're also going to measure out, where is my carbide? You're going to, in the jar with the silicon carbide. put most of the silicon carbide into the plastic jar. So you're going to use most of this in here. Now, I'm not opening this because this will be difficult to replace. This is going to provide a lot of abrasion elements in there. But you're going to pour that in there. Leave a little on the side just in case the experiment doesn't go well. So once all that's together, once you've got your water, carbide, and gravel in there, you're going to shake it for 5 minutes. And that doesn't mean shake it like it owes you money. Shake it. Okay, so you're going to really shake it like crazy for about 5 minutes. If you don't shake it like crazy, you're not going to get any effect whatsoever. Once you're done doing the shaky, you're going to take it out. You're going to dry it off. You're going to let it dry and then measure it again. Now, I'm going to give you a hint. Granite's not going to change very much, but at least one of these and maybe both of these is going to change fairly substantially. Once all the rocks are dry, record the final mass, and then we do cleanup. Now we're going to go on to the next exercise. We're going to do chemical weathering. So you're going to put on your safety goggles. The acids in this are not super dangerous, but you definitely do not want to get them in your eyes. So most important, if you're working with your bare hands, make sure that you wash your hands before you do anything else after working with these acids. Because if you rub your eyes, you're going to have a spicy day. It's not going to be great. So you're going to go ahead and you're going to, it says, I've told them about this, to measure 75 milliliters into each beaker. No, they fixed it. It was, yeah, the numbers didn't work out well before. So 75 milliliters into each beaker. There's 230 milliliters here. That means you'll have a little tiny splash left at the bottom if you measure correctly. And you're going to put them in each of the beakers. And you're going to secure it with a rubber band. Take a picture, and you're going to let it sit for an hour. Gently swirl each beaker to mix the acid. And then you're going to set the timer for 3 more hours and wait with the beaker in there. This is a good one to do in the evening, right when you come home from work or something like that, and just set it up while you're making dinner or whatever, and then check it before you go to bed. So, because it does take a while. Definitely put it somewhere where the pets aren't going to knock it over. Then you go ahead and you enter your data from your chemical weathering experiment. And then we go to our last experiment. Now notice this is one of those typos, experiment name here. This is slope stability. So they didn't enter the experiment name. I send them a lot of emails. So I'm going to clean up after this one. Give me a second. I'm going to put my, you don't want to put any of this, if you're going to reuse it, you don't want to put any wet stuff back. I do, if you're an elementary ed major, which many of you are, this kit, you get to keep this kit. And I would recommend keeping this kit because it'll give you ideas for when you're an actual teacher. So in this experiment, you're going to measure out 200 milliliters of fine gravel. At this point, the gravel should be dry. Into your beaker. So once again, it's hard to measure gravel. Gravel is not a liquid. So we're going to go with good enough. You can see I used almost all of the bag. Got a little bit extra in there. There we go. Now I've got about 200 milliliters of 200 cubic centimeters, which is the same as 200 milliliters of gravel. I'm going to pour out my gravel as carefully as I can. I'm going to wait for that to settle. It looks like it's pretty settled. This is as settled as it's going to get. And then I'm going to go back to my kit. And I am going to grab a protractor. So a protractor looks like this. It's for measuring angles. And you're going to use your protractor to attempt to measure the angle of repose. Now it takes a little practice, but I can see for this gravel right here, the angle of repose is about 30. You want to be pretty well level, like your eye needs to be kind of level with the table for this to work well. But it's also just an estimate, okay? Just don't be measuring it from up here, because if I look from up here, it looks like it's 80. But if I go down on the side like this, then it's clearly the angle is about 30. And then you're going to take pictures of your piles of dirt to prove that you actually measured your piles of dirt, and then enter the data, and then you're all done. It's really not very complicated. It is messy. This is definitely, if you have a nice big kitchen, that's a great place to do this. Also, if you live in the res halls, you may not want to do this in your room. You may want to do this downstairs somewhere, like ask Matt. Elsewise, it's a pretty straightforward experiment, but yeah, it can get pretty messy pretty fast, and you really don't want pets, because pets can really mess things up by knocking over the acetic acid and all that kind of stuff. So wherever you're working, try to keep it as pet-free as possible. So if you live on campus or near the campus and you would like to use my lab for this particular experiment and walk through it with me, don't be afraid to reach out to me. I'm happy to do that. I've got a big lab space here with lab benches that you can work on.